Hello children, today we are going to start a new chapter, cubes and cube roots. Now in this chapter we are going to study the power of a number, and the power here is going to be 3. In last chapter we studied the power of 2, that is square. In this chapter we are going to study the power that is 3, which we will call it as cube, and then we will find the cube roots also in the next part of the chapter. Now let's begin with cubes. Now before we start that, we have a little story about one of the India's great mathematical geniuses, S. Ramanujan. Once another famous mathematician, Professor G.H. Hardy, came to visit him in a taxi whose number was 1729. While talking to Ramanujan, Hardy describes this number as a dull number. Ramanujan quickly pointed out that 1729 was indeed interesting. He said it is the smallest number that can be expressed as sum of two cubes in two different ways. Cubes added together in two different manner, and this is the smallest number that has this possibility. This is what Mr. Ramanujan says. Now here is the expression of what he actually meant. 1729 is addition of 1028 plus 1. Now 1028 is cube of 12 and 1 is cube of 1. Addition of both these cubes give you this number. And again 1000 and 729. Another two set of cubes. So 1000 10 cube and 729 is cube of 9. So addition of both these cubes give you the same number. That's why it is an interesting number. That's why this number is given the name Hardy-Ramanujan number. And this is a feature that we have to understand, that there are interesting things that we can do with number. There are different patterns, and these patterns help us to make mathematically intelligent, mathematically intellectual. So this person Ramanujan and the person Hardy, both of them were geniuses, mathematical geniuses. That's why their talk, the excerpt of what they talked, is given as an introduction for our chapter cubes and cube roots. Now let's go ahead with the chapter, and in here we have number and its cubes. So when these are the cubes, how exactly do we find a cube? For finding a square, we multiply the number with itself. That means two of the numbers are multiplied. While we are doing the cube, we multiply 3 times the number with itself. That means 1 multiplied by 1 multiplied by 1. There are 3 ones. That's why the power is given as 3. And when you multiply, what's the answer you get? That's called its cube. Similarly, 2 into 2 into 2. 2 2s are 4, 4 2s are 8. 8 is the cube of 2. And how do we represent this? We represent it in this manner, 2 to the power of 3. Now here we generally don't say 2 to the power of 3. We call it 2 cubed. 3 cubed is 27. 4 cubed is 64. And likewise, the rest of the cubes are also given here. 5 cubed 125, 6 cubed 216, 7 cubed 343, 8 cubed 512, 9 cubed 729 and 10 cubed 1000. These are the cubes. Now based on this, like I said, the patterns are important, and here the pattern that we could see is when a number is odd, the cube is odd. When the number is even, the cube too is even. This is what we could observe from this. And then another interesting fact that we must know is, say 1 cube is 1, 2 cube is 8, 3, 7, 4 is 4, 5 is 5, 6 is 6, 7 is 3, 8 is 2, 9 is 9 and 10 is 0. All the numbers are in certain fashion. All of the numbers are there in the cube. Say we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9 and we have 0. All the numbers from 0 to 9, all the one-digit numbers are seen in the ones place. Now this is the fact that we have to use in the next exercise. We'll come to that when we discuss it. Now let's move ahead with the chapter, and here is a pattern, adding consecutive odd numbers. We had seen similar property with the squares. When you add number of odd numbers, as many odd numbers you are adding, that's the square of that number. So that's how it is similar to that. See, 1 is 1 and the next 2, when you add, you get cube of 2, and after this 5, 3 more you have to add, so you get cube of 3. Means it's in increasing order. The manner is in increasing. There's a trajectory. It's going on increasing. 1, then we have 3 and 5, then we have 7, 9 and 11, and then after 11 we have 13, 15, 17 and 19. And then after 19 we get 21 as the next odd number, and then addition of 5 odd numbers after that gives you the cube of 5. Similarly, if we say after 29 comes 31, and from 31 if you add 6 consecutive odd numbers, you will get the cube of 6. This is how the cubes have a certain factor. Now, how to find the cube root? Now, to find cube root, we use prime factorization method. Now, prime factorization we have already studied in class 6, class 7, and now in class 8 again we are doing the same. Even in this finding square roots, we used prime factorization. The similar method is used here. In finding squares, we made the groups of 2. In here, for finding the cube root of a number, we make groups of 3 because the power of a number is 3 when it is cubed. So here 216 is a number, and this is the prime factorization of the number. And when you are factorizing it, you see there are 3 2's and there are 3 3's. Both of them are grouped in different in a pattern in a group of 3. So next, how do we find the cube root? Out of these 3 we take only 1. Out of these 3 we take only 1 and multiply them. And that's the cube root of this number. Now, to signify a number's cube root, this is how we use. We put the symbol of the square root, but since here the power is 2, that's why we put the number 3 here. This signifies that the number this is the cube root of that number. To signify cube root, we put this symbol, square root symbol with 3 on top. It is cube root. That's how we must understand. Now, cube root of 216 is 6. How did we get that? We factorized it, prime factorization, made groups of 3, and then took 1 from each group and then multiplied them, and that's how it works. Now we come to exercise 7.1. Which of the following numbers are not perfect cubes? Now we have to do prime factorization, and then if the groups are not of 3 each, then the numbers are not perfect cubes. So first one, we have 3 2's and 3 3's. So there could be groups of 3 each. Different numbers, yes, but there is a group of 3 on either side, for 2 and for 3. Both of the sides we have 3 each. So it's a perfect cube. 128, 3 is 3 times, but then 2 is only 2. So that's why this cannot be a perfect cube. So you have to write it there that this is a perfect cube, this is not a perfect cube. This again, there is a group of 3 2's here, there is a group of 5, the 3 5's here. So it is a perfect cube. So 1000 is a perfect cube. 100 we have groups of 2 each. There are 2 2's and there are 2 5's. So quite naturally it is not a perfect cube. Find the smallest number by which each of the following must be multiplied to obtain a perfect cube. Now here the numbers that we have are not perfect cubes. And since it's not perfect cube, what will you do to make it a perfect cube? Here there are 2 ways. One way is to multiply with some number, and second method is to divide. Now in this question we are asked to multiply to get a perfect cube. What is the number that should multiply this particular number so that the number becomes a perfect cube? That's what the question means. Now let's see what we need to do. 243. This is our number. Now 243. First step would be to factorize it. And on prime factorization, we see that there is a group of 3 3's, but then second group is lacking 1. There are only 2 3's, so 1 3 is missing. There has to be 3 3's. So in here we have 3, but here there are only 2. So what we should do is that one that is missing should multiply with the question, that is 243. When you multiply 243 with 3, you get 729. Now 729 is a perfect cube, but of which number? Of a number 1 from each. So 3 and 3. 3 3's are 9. So 3 into 3 cube is 9 cube, that is 729. Or you could mention it like this, cube root of 729 is 9. How did we get 9? We make groups of 3 and then take 1 from each group. That's how we find the cube root. So this is how it is done. Now the second question, 256. Now 256, when you do prime factorization, you could see there is a group of 3 2's, another group of 3 2's, but the third group of 2's is only 2. So what we need is another 2 here so that it becomes 3 2's. So what we do, 256 multiplied by 2, which you which gives you 512. And 512, whose cube is this? Which number has 512 as its cube? So to do that, one from each group, 2, 2, and here, because we already multiplied here, so one more 2. So 2 into 2 into 2. 2 2s are 4, 4 2s are 8. So cube of 8 is 512. Or you could mention it like this, cube root of 512 is 8. Next, 72. Now 72, we already know 72 is not a perfect cube, as the question already stated that. Next step would be to make prime factorization. After prime factorization, this is what you see. Now here, as you can see, there are 3 2's, but the 3's are only 2. So what we need? One more 3, so that the group gets completed. So to get that 3 there, we have to multiply the 72 by 3. Now 72 multiplied by 3 is 216. Now we know that 216 is a perfect cube, but of which number? So to do that, we just have to say there is already 3 2's, so 1 taken out, and here 2 was there, 1 we added, so there is a group of 3 3's. So 1 3 comes here, so 2 into 3, 6, 6 cube is 216. Or as we already discussed, cube root of 216 is 6. Find the smallest number by which each one of the following numbers must be divided to obtain a perfect cube. Now here the second method is going to be employed. Here we are going to divide the number in such a way that you could get the perfect cube. Means the numbers which do not have groups would be removed. Now how do we do that? 81, when you factorize it, this is what we see. There is a group of 3 3's. But then there is one 3 which doesn't have any group. Means it doesn't have any pair. Now if we were supposed to multiply, what we would do? We would multiply it with 3 into 3, that is 9. But since here we are asked to divide, so we remove this 3. To remove this 3, we divide this 81 by 3. Dividing 81 by 3 would give you 27. Now this 27 is a perfect cube. Of which number? There are 3 3's, so 1 3 taken out. So that's your perfect number. That's the number that whose cube is 27. So 3 cube is 27, or cube root of 27 is 3. That's how we'll write it. Now 128. Again we see there are 3 2's, and 1 2 which doesn't have any group. So this 2 is going to be removed. How? By division. So 128 divided by 2 gives you 64, and 64 is a perfect cube. Perfect cube of which number? This number and this group. Take 1 from each. So 2 2's are 4. So 4 cube is 64, and cube root of 64 is 4. Either way you write, it means one and the same. Next, 135. Now 135, it's not a perfect cube as already mentioned. So we do the prime factorization, and we see that 5 is alone. It doesn't have any group. So we remove the 5 by division. So when you divide this 135 by 5, you get 27. And 27 is a perfect cube. Cube of 3, because these 3 are group. And one out of them has to be taken out. This 5 already we removed by division. And what's left is only this group. And this group has 3 3's. So 1 taken out. So you get 3 here. So 3 cubed is 27, or cube root of 27 is 3. Next. Parikshit makes a cuboid of plus a sign of sides 5, 2 and 5 cm. How many such cuboids will he need to form a cube? Now here we have to understand the concept of cubes and cuboids. Cubes are square boxes and cuboids are rectangular boxes. What does square do? All the sides are equal. And cuboids, all the sides are not equal. That we can say it's a rectangular box, a box which is rectangular, which has rectangular faces. Now here this boy Parikshit has made a cuboid, and the sides are 5, 2, 5, and he has to make cube out of this cuboids. Many blocks he has, and he has to make a cuboid. So how many such things are required? So to do that, what we have to see, 2 into 5 into 5. Now, if we see, there's only 1 2 here, and there are 2 5's here, and we need a cube. Cube means there should be groups of 3. Since there's only 1 2, we introduce 2 more 2's. Since there are 2 5's, we take 1 5. So these and this are added. This is something that we are multiplying are actually existing measurements. So what we are going to do? 2 into 2 into 5. 2 2's are 4, 4 5's are 20. Now this 20 is our answer. These many cuboids are required to make a cuboid using these cuboids. Make a cube using the cuboids of this dimension, length, breadth and height. So all of it must be equal. That's why we have to have 20 cuboids of this dimension to make a perfect cube. So he will need 20 cuboids to form a single cube which has these dimensions. What would be the dimensions now of the recently made cube? It would be, see, 20 into 50, whatever the answer comes, is 1000. So 1000 is our perfect cube. Now 1000 is perfect cube, but cube of which number? 10. So each of the side of this newly formed cube would be 10 centimeter each. That's what it means. So we have a number which has to be multiplied with another number to make it a perfect cube. Now here 50 is our pre-existing number. It's given in the question. We need to find a number which would be the least, but when multiplied with the number in the question would give you a perfect cube. Since we have 50, that is 2 into 5 into 5 is 50. 50 in our question, already mentioned there. Now, what we are going to do is we are going to get the smallest number possible. The smallest number possible is 20. How did we get this 20? Because 2 was alone, we gave it to two partners to make it a cube, and 5 was squared, and we need one more to make it a cube, so 1 5 was introduced. And these numbers which were introduced, that is 2 into 2 into 5, would be the recent number. So 2 2s are 4, 4 5s are 20. So 20 multiplied by 50 gives you 1000. Now 1000 is a perfect cube. That is why we should say 20 cuboids are required by this person to make it a perfect cube. That's about this exercise. Have a good day.